Welcome to The Explainer. Today we're tackling the biggest story ever told, 13.8 billion years of history, from the very first moment of existence all the way to the sprawling, star-filled cosmos you see in the night sky. This is the story of, well, everything.
But think about it. How do you even make a timeline for the whole universe? For our own history, we can just pick a reference point, a year one, right? But for the cosmos itself, where do you start the clock? What's the starting pistol for time itself?
Here on Earth, we mark time using epochs. The beginning of an empire, a major revolution, the dawn of the internet. They're the chapters in our story. Well, the universe has its own chapters, its own epochs, but they play out on a scale that is it's almost impossible to wrap your head around.
So let's do it. Let's wind back that cosmic clock. We're going to take a trip through the most important moments, the turning points that literally wrote the rules for the reality that we live in today.
Okay, first things first. We need to get a handle on the sheer scale of this timeline. Just how old is our universe anyway? 13.8 billion years. That is our best estimate. It's a story that starts in an unimaginably tiny speck of heat and density, and then just blooms into the vast, structured cosmos that we call home. Now, you might think that something as big as a universe would take its sweet time getting started. You'd be totally wrong. The most crucial, reality-bending moments were all over in less time than it takes you to blink. In the very first seconds, the entire rulebook for our reality gets written. We start in the Planck epoch, a moment so early, so extreme that our current laws of physics they don't apply. Then, bam, a period of inflation kicks in, and the universe expands exponentially, going from subatomic to absolutely colossal in an instant. This leaves behind a superheated soup of particles, the quark epoch. A chaotic plasma just way too hot for even a single proton to hold itself together.
So think about it like this. In the very beginning, the universe was perfectly simple, with all of nature's forces blended into one single superforce. But as it expanded and cooled, that perfect symmetry shattered. The forces froze out and split apart, one by one. And that very separation, that's what made everything else, matter, atoms, stars, us, even possible. All right, for the next few 100,000 years, the universe was in this really strange state. It was filled with light, but it was totally impossible to see through. It was just a glowing, impenetrable fog. And the reason for this cosmic fog? Well, the universe was still a chaotic plasma of charged particles. Photons of light couldn't get anywhere. They'd travel a tiny distance and just smack right into a free-roaming electron and get scattered. It was like a cosmic pinball machine. Light was bouncing around everywhere, but it was completely trapped. And then the great clearing began. As the universe continued to cool, electrons were finally captured by protons, forming the very first stable neutral atoms. With all those pesky free electrons now locked away, the path was suddenly clear. Light was finally set free to travel across the cosmos. The fog lifted, and for the very first time, the universe became transparent.
And here is the absolutely incredible part. That very first light is still traveling across space today. The expansion of the universe has stretched it out into microwaves, but we can still see it. It's called the cosmic microwave background, and it is, no joke, a literal baby picture of our universe just 370,000 years after it was born.
So the lights came on, but the universe was still mostly just empty hydrogen gas. How did it go from that to all the galaxies and stars we see today? Well, this is where gravity takes center stage. After that first light was freed, this kind of eerie silence fell over everything. This period is known as the Cosmic Dark Ages. The universe was transparent, sure, but there were no stars, no galaxies, nothing was creating new light. It was just a vast, expanding, and totally dark place. But gravity was patiently at work, and it had a secret weapon, an invisible substance called dark matter, which had been clumping together all along, formed this huge cosmic web. This invisible scaffold was basically the gravitational blueprint for the universe. Ordinary matter was pulled into these filaments, gathering into dense clouds that eventually collapsed and ignited, lighting up the cosmos with the very first stars and ending the Dark Ages. For the next several billion years, gravity was the star of the show, pulling everything together and actually slowing down the universe's expansion. But a mysterious new player was about to completely change the game. Yeah. Observations of distant exploding stars showed us something absolutely shocking. Instead of slowing down, the expansion of the universe was actually speeding up.
Something was out there overpowering gravity on a cosmic scale, pushing everything apart faster and faster.
The culprit is a force we call dark energy. And get this, it turns out everything we can see, the stars, the galaxies, the planets, that makes up less than 5% of the entire universe. The rest is this mysterious energy woven into the fabric of space itself. As the universe expanded and matter spread thin, gravity's pull weakened and dark energy's push just took over.
So what does this accelerating future hold for us? Well, cosmologists have a few ideas, and each one is more dramatic than the last. The most likely is a heat death, where the universe just expands and cools forever into a dark, empty state. But there are wilder possibilities, like a big rip, where dark energy tears apart the very fabric of space-time, or maybe even a big crunch, where the expansion reverses and the whole universe collapses back in on itself.
So from a single point to an accelerating cosmos, that's our 13.8 billion years story. Every step, from the forces separating to that first light escaping, was absolutely necessary for our own existence. We've learned so much, yet the greatest mystery of all remains: what happens next? The final chapter of the universe is still unwritten.